In this video, I'm going to give a demo or a quick walkthrough of this notebook, which is hyperparameter tuning tutorial. Let's begin. With the first coding cell, we begin by installing and importing essential libraries, including Optuna, which is a powerful framework for hyperparameter optimization. The output shows the installation progress and confirms that all dependencies are ready to go. Next, in the second cell, we create a simple neural network and a synthetic dataset to demonstrate just how much hyperparameters can affect our results. The printed text emphasizes a key insight. Simply changing the learning rate can be the difference between successful training and total failures. In the next cell, this code visualizes the theoretical landscape of learning rates, showing how accuracy changes as the learning rate increases. The result graph highlights the sweet spot where learning is optimal, flanked by regions that are either too slow or completely unstable. Next, we implement a learning rate finder, a technical technique that gradually increases the learning rate during a test run to find the best starting point. The output graph clearly pinpoints the ideal learning rate before the loss spikes, suggesting a value around 0.00027 for stable training. Next cell, we set up a classic grid search defining a list of learning rates and height sizes and systematically testing every single combination. The log prints out the accuracy for each combination, eventually finding the best pairing of a 0.01 learning rate and a 64 hidden size which hits 99% accuracy. Next, we visualize the result of a grid search by generating a color code heat map. The output plot shows exactly which area of the hyperparameter grid produced the highest accuracy, with green cells representing the best performance. In the next code cell, we create a visual comparison between grid search and random search to show why random sampling is often superior. The output graph and text explain that random search is more efficient because it tests a wide variety of unique values for each individual parameter. Next, we put a random search into practice, letting it sample hyperparameters randomly across a different range for 20 trials. The printed output tracks the best score over time, showing how it quickly discovers a highly accurate model configuration without exhaustively searching everything. Finally, we bring in Optuna to perform Bayesian optimization, a smart search that learns from past trials to guess better hyperparameters in the future. The log shows Optuna rapidly exploring combinations of learning rate, dropout, and hidden layers quickly, honing in on top performing setups. In the last cell, we extract the results from our Optuna study and plots its optimization history and parameter importance. The output graph shows the validation accuracy climbing over time and a bar chart revealing which hyperparameters actually had the most impact on the model success. So this is just a summary or a cheat sheet to sell further on, and that's it with this collab demo. Thank you.